Right, over here, got a soldering bolt. Right, this is going to get very hot. The only place it sits when it's not in use is in the holder. We've got a sponge here, which is for cleaning the soldering bolt. It's been made wet by the tap. Alright, and I've got a supply which is on an RCD for safety. When you're doing soldering, you want to make sure that you're wearing a pair of goggles. Okay, I have opted not to wear goggles because I'm going to have to wear these because my eyesight's pretty horrific, but at least the lenses on this offer me some more protection. So I'll put my face mask on. Certain things that we never ever do with a soldering bolt. So you're never ever going to leave the soldering bolt lying on the table like that because it'll burn holes in the table. You're never ever going to put the soldering bolt anywhere near the power supply or its actual flex, and the way you achieve that is by sticking it in there when you're not using it. Also, students tend to think that it's a good idea to grab a length of solder and just melt it. That's not what we do with solder. The solder is for fastening components such as resistors onto copper strip board. So on your copper strip board you have a bottom copper side, so get a right close up of that, which has long strips of copper. They all run in the same direction, but one strip, grab this pick here, one strip is not connected to the strip next door. Okay, but an entire row, an entire column like that, or run, is all connected to each other.
That's a sheet work.
Okay, right. Kind of taking a video for your class just now, guys, so keep it down a wee bit. Alright, so this is the bottom copper side where the soldering goes. So you would take components such as this, you get a pair of needle nose pliers and bend them to the required shape, just like that. And usually it's, if you look very closely, you can see that it's, you bend the legs down so that they're sort of coming down from the shoulder in a straight line. Now, the components go into the board from the top silk side. Right, so if I look at the direction my tracks are going, I'm going to pop it in. There's a gap of maybe 2, so if I point at that, 2 little holes there, that means that this component will just settle and fit on the board nice and neat. If you leave too many gaps, you're going to have excessive wire, excessive lead length across here. That can lead to shorts and things. I'm just going to take this mask off because it's muffling everything I say. Now, look how one leg will get soldered into one track and the other leg into a completely different track. That means that if we make this track here live, the electricity will travel through the component to a different track. Now I'll show you the wrong way to pop it in. So if we pop that back out, if I pop them in so that both leads, both legs of the component are on the same track, then that component is actually shorted out. Electricity always takes the easiest route, and for electricity in this case it's just to go straight down the copper track. It's going to completely ignore this component. Okay, so let's get some soldering done. I'll just pop that out manually and stick it in here. I'm using any old random resistor for this for practice. But I'm certainly not using the ones that we use for the actual circuit because I don't want to waste them. I want to keep those for the actual circuit. So we've given our, I'll just clear a bit of space here, pop that over there. We've given our soldering bolt plenty time to heat up. So I'll just pop that on down here. If we go back to the soldering bolt, you see the end of it? It's all sort of yucky and covered in burnt, what is called flux. Flux is a flowing agent that's in the solder that helps it actually flow and attach itself to the copper and the legs of the component. So I need to clean off all this rubbish. That's why my sponge is wet. You hear it sizzling away. If the sponge isn't wet, what you'll end up is just getting more burnt rubbish on the end of the soldering bolt. See how much cleaner that is now? Much better. I'm going to take a little bead of solder just to make sure, and just hold the solder against the soldering bolt tip like that, and you see I can put a bit on there and a wee bit on this side, nice and shiny. I'm going to just immediately wipe that back off as best I can, and it should be even cleaner. When the solder melts on the tip, what it does is all the rubbish that's stuck to the tip that you didn't manage to clean off will float on top of the solder, and then you lose it on the sponge. So I'll just pop that there just now. It's get this piece of paper out of the way because we don't want any fire hazards. And we'll do a solder. Now before I do, I'm going to stick my glasses on. You get to laugh once, so you can let them see me if you want. Yeah, look like a complete idiot, but at least I can see. Right. So solder here. Now the soldering itself is pretty straightforward. What you want to do is take the soldering bolt, tiny little bit of solder on there just to give this something to melt to when we start using it. I'm going to hold it against the board and against the leg of the component, and I'm just going to wait till both have had sufficient heat and then pop in a little bit of solder like that. And that's a dry solder. That's the first one, always turns out like that. So in again. Now that's excessive, okay, but it's still a good solder in the fact that you don't have any additional solder bridging over onto the next track. Now the more you do, the easier this gets, and it's been a while since I've picked a soldering bolt up, so that's probably why the first one was a bit dodgy. So a bit of heat there, and I'm going to apply solder into the gap. That's much better. That's more like the amount of solder that you require. Right, now see how it makes a kind of metallic molehill. If I hold that up and you see that cross section there, see if you can zoom in on that right. You'll see that the board's flat, and then you have like a little mountain of solder that comes up, climbs up the leg of the component, and then climbs back down. And it should be kind of symmetrical. That's just the right amount of solder for this job. This, too much. Just enough. And I'm going to do a couple more components. So put the soldering bolt back in its holder. Sorry, get the pliers. Sort it out. Get the component sitting nice. And turn it over to the silk side, and let's just pop it in there. I mean, it doesn't matter where you put these if it's for practice, as long as they're nice and flat on the board like that one. So we can get rid of the legs of the previous component because they're just going to get in the way. So I'm just going to snip that off down there and snip this off down at the bottom here. So they're gone. Grab my solder again. Now that bolt's been sitting a while, so we'll give it a clean. Now, if the bolt becomes really dirty to the stage where that won't clean it, you've got another tool here. It's just a piece of it's kind of like a Brillo pad for doing the dishes. It's made out of brass, and that'll scratch off any residual rubbish that you get on the soldering bolt. But that's a sort of, you shouldn't have to go near this. Should be able to do it all here. Just going to apply a tiny little bead of solder there just to give us something to work with. Wipe it off again. See how much cleaner that is? There's still a wee bit of solder there. Right, I'm going to try and do that dry solder on purpose so that you can see what a mistake will look like. So if I hold that in there, I'm not going to give it enough time, I'm just going to go whack like that. Easier than I thought it would be. Right, so looking at that, There's not. See if you look on this side. See there. You can see that there's solder missing. I don't have this little molehill type thing that I was trying to do over here. That's good. This is bad. There's not enough solder on there. That's a dry solder. That leg could, I mean it's still quite secure, but it could come loose. So I've got to see how to fix that. You can see that there's some missing. I can get the pick in there. Yep. So how to fix that is quite straightforward. You want to avoid these mistakes as much as possible. So I'm just going to reheat that solder. It doesn't take long to melt. Wait till that heat settles, and I'm just going to feed that joint there with a little bit more, and it will eventually flow. So that's a wee repair job done there. That's perfectly serviceable now. I'm going to show you something else that can go wrong. Okay, so what I'm going to do is I'm going to deliberately heat up this leg of that component, that resistor, for far too long. So I'm just put the bolt on there. Now I don't want you to try this on purpose, but I'm going to do it this once just to let you see what happens. So we just keep applying heat, keep applying heat, keep applying heat. This is way too much. You might even see some smoke appearing. It's not good. It's not good for the soldering bolt, it's not good for the component definitely, and it's not good for the board. Sometimes it can cause the copper to actually lift off of the board. We don't want that. So that's maybe enough. If I turn that over, must be a wee bit more robust, these components. We'll give it a bit more. Maybe I'm just not getting the heat into it. I'll add a tiny bit of solder just to aid the heat getting through. Now, essentially what I'm trying to do is cook this component, let you see what it looks like when it's completely destroyed. So the solder's just going to aid that heat transfer between the bolt and the leg of the component. Now when you guys are working, you should really have goggles on, because what I'm doing just now could cause the solder to spark or spit up, and you certainly don't want molten solder in your eyes. It could blind you. But I've got glasses and magnifying glasses on, so pretty sure I should be okay. Now, again, what you can see is round about that leg, you can see that the board's become charred. I was quite expecting this component to look horrible and charred as well, but I can guarantee you one thing: the length of time I heated this up, that component will have failed. So don't overcook. Okay, let's try and do a couple more solders. I'll just get sorted out for that. I'm going to remove that and remove this. I'll just bend these with my fingers just for the speed of it. It's nothing wrong with you using your fingers to do this. And we'll just put one in there. One next door to it. I hope you chaps aren't just sitting on mobile phones. Don't come to a standstill. Three will be enough. You'll get the idea of it from three. So there's three components. Going to clean the bolt. There will be rubbish on it now from that burning event that we did there. Got components stuck to my arm. It's fantastic. Now you don't need much solder, so wee bit on there, wee bit on there, wipe it off. Get that away from the power supply a wee bit, and I'm just going to apply the heat there. Hold the board down with your spare finger, bit of heat. That's flowed. come round a little bit. There we go. Just feed it till it flows. Feed it till it flows. See, the more you do, the faster it gets. Feed it till it flows. Last one. Don't go too short with the solder, because the last thing you want to do is stick your finger on the end of this soldering bolt. Feed it till it flows. Whirl it around a wee bit. And feed it till it flows. So I'll pop that in there. Now you'll see between each track, well, you've got copper strips which are attached to this resin side, the top silk side. The solder won't stick to that resin, so it automatically forms like, you know, it won't jump over unless you completely overload it. Maybe that's something we should show you. So I'll get another bit of solder. This is getting a bit short for safety's sake. I'll put a little bit on here, and then I'll just try and sort of add too much. We'll see what happens. I mean, there's a lot of solder on there, it still hasn't jumped over, but if I get that bolt in the wrong position and I start applying heat over there, you will see that eventually it will flow into a big puddle, and you don't want that. That would be a short circuit, assuming you've got other components on here, that rail. So we'll just chop those off. It's good to have goggles for this part as well, because sometimes the pins on these can sort of spring off into there when you clip them, and again that's something you don't want in your eye. Right, so there's 3 components soldered into the board. What I would suggest is, see how you've got nice flat components. These are very close down to the board, so I would put them on first, and then you've got taller components like this capacitor here. We'd do these last if you can, because otherwise what you might end up with is a component that falls off the top silk. I'll try and sort of let you see that. I'll have to sort of do it on purpose. I'll have to jimmy this a wee bit so as it demonstrates what I mean. So if you start with all the flat components that are close to the board, and then work forwards in order of how tall the components are, you can help avoid this situation that I'm going to engineer on purpose here. Right. Now, you don't want that. See this component sitting up in the air like that? That's no use. Why? Because it can twist, it could maybe even short itself out, see? Or it could fold over and touch some other component and cause a short circuit. So all the components need to be into the board, as close to it as you can. So I'll just pop this one in as well. See, sitting quite close to the board, bang on it in fact. A tiny wee bit of gap is not a bad thing, it allows for cooling, but on a tiny wee circuit like this we can afford to have them flat down. So what I would do is try and balance that somehow. Soldering bolt in one hand, watch your fingers, back up a wee bit. I'm just going to get the solder ready. Right, you can come in now. Yeah, what did I forget to do? Clean the soldering bolt, but you know, it'll be okay. And just apply a bit of heat, get it flowing, turn it around, get the other component, the other leg rather, and get it flowing. And that should be enough. So, oh, see that? That hit you?
No.
No, good. That one just about did. And there you have the components on. See that big puddle of solder that I did on purpose? You can see that's actually started to cook the board from this side as well. Okay? Yeah, soldering. There's not much more to it than that. So keep the soldering bolt clean. Don't forget to apply a decent amount of heat, otherwise it won't work, and don't apply far too much solder, and keep all the components flat down on the board. Do it in a logical approach.